In this problem, you are asked to see whether a discrete time signal x of n given by cosine n over 8 is periodic or not. So the way I think about solving these problems is to say, if the signal were periodic, then there must exist a capital N such that x of n is the same as x of n plus n. Do you agree? Okay. Now, if I am able to find such an n, then we can say that the signal is periodic, and the smallest positive value of such an n would give me my time period, because that's how we define the time period. But one thing you have to be careful about when dealing with discrete time signals is that n also has to be an integer. Because discrete time signals are defined only for integer values of time, right? So n has to be an integer. So if you get answers where n is not an integer, then those are not valid time periods. Okay, so let's see whether this is possible, whether we can find an integer value for capital N such that x of lowercase n is equal to x of n plus uppercase n for all lowercase n. Okay, what is x of n? X of n is cosine n over 8. What is x of n plus capital N? This is cosine n plus n over 8. Now this is the same as cosine n over 8 plus capital N over 8. Alright. So when would these two cosinusoids be the same? For what values of capital N would they be the same? So can capital N be equal to 0? When capital N is 0, certainly this is true, right? But that's a trivial answer, because capital N being 0 means that you are not really shifting that signal at all. So we are looking for this smallest non-zero capital N, which is an integer for which this cosine n over 8 would be the same as cosine n over 8 plus capital N over 8. Okay. Now, the only way these can be true, the only way cosine n pi over 8 is the same as cosine n over 8 plus capital N over 8 is if n over 8 is an integer multiple of 2 pi. So let's say that means it has to be of the form k times 2 pi, where k is an integer. Why is this true? It's true because you know that cosine theta is the same as cosine theta plus any integer multiple of 2 pi. Cosine function repeats itself every 2 pi. Okay, right? So then the question is, can I find such an integer value of n? Well, now if you look at what you have here, so if we can find such an integer value of n, then what this would mean is that n over 16k would have to be equal to pi, right? Now we know that we want n to be an integer, and we know that k is also an integer. So what I have on the left hand side here is a rational number, but we know that pi is not a rational number. You cannot write pi as a ratio of two integers. So this is not possible. So what that means is there must not exist an integer value of capital N such that we can have n over 8 to be an integer multiple of 2 pi, or equivalently we cannot have cosine n over 8 to be cosine n over 8 plus capital N over 8. Therefore the signal is not periodic. Okay. Now it's tempting to look at cosinusoids of the form Generally, if you have a cosinusoid, if x of n is of the form cosine omega naught n, then omega naught can be thought of as the angular frequency, right? Now this is tempting to say that this is true for all omega naught. I mean, it is true for all omega naught, but it turns out that these cosinusoids are not periodic for all values of omega naught. Okay, particularly what this has shown us is that if omega naught is 1 over 8, the resulting cosinusoid is not periodic. Okay, so what we would really need is omega naught would have to be some rational multiple of pi for it to be periodic. So 1 over 8 is not a rational multiple of pi. That's why it's not periodic.